Most people would walk past this rock without a second glance. No visible gold, no sparkling crystals, no obvious sign of value. And yet, an experienced field geologist might stop immediately, not because of what stands out, but because of what most people overlook. Look closely. A subtle rust-colored stain traces a network of tiny fractures. It isn't bright, it isn't dramatic, it doesn't demand attention, and that's exactly why it gets ignored. Opportunities like this aren't hidden because they're invisible. They're missed because they're misunderstood. Across deserts, mountains, and quiet hillsides like this one, people walk directly over evidence of mineral wealth every single year, never realizing what was beneath their feet. Not because the gold wasn't there, but because the knowledge wasn't. To a prospector, this stain isn't decoration. It's a question. What mineral once filled these fractures? And what geological process left this trace behind? Gold itself isn't especially rare in Earth's crust. Tiny amounts exist almost everywhere. The real challenge has never been finding gold. It's understanding where geological forces have concentrated it. That's where knowledge becomes more valuable than the metal itself. A trained geologist doesn't begin by searching for gold. They search for signals. Signals created by pressure, by heat, by fluids moving through rock over millions of years. Pay attention to the structural framework. A thin white vein cuts across the host rock. At first glance, it seems ordinary. Quartz is one of the most common minerals on Earth. Most quartz veins contain nothing of economic value. So why does this one matter? Because context defines meaning. Where is the vein located? Does it follow a fault line, a fracture system, a shear zone? Fluids don't move randomly through solid rock. They follow pathways. Without those pathways, mineral-rich fluids can't circulate. And without circulation, valuable deposits rarely form. This is why experienced prospectors study structure first, and visible gold last. Examine the direction of the vein. It extends beyond what the eye can immediately see. That suggests continuity. And continuity changes everything. A single vein might mean nothing. But an interconnected network, that's where probability begins to build. Now compare the surface. Weathered rock hides information. Fresh rock reveals it. The color shifts. The texture sharpens. Details begin to emerge. Tiny metallic grains appear within the rock. Not gold? Not yet. More likely sulfide minerals, pyrite, arsenopyrite, or something closely related. And that matters, because sulfides often act as markers, part of a larger evidence trail that points to past fluid activity. These fluids don't carry just one element. They transport complex chemical mixtures. As conditions change, temperature, pressure, chemistry, minerals begin to form. Quartz may crystallize, sulfides may deposit, and sometimes gold forms alongside them. Sometimes it doesn't. That's why geologists don't chase gold directly. They follow the mineralizing process that could have created it. And here's where it becomes real. These exact relationships, structure, quartz, sulfides, have led to discoveries worth millions, in some cases, far more. And before they were understood, they looked just as ordinary as this. The prospector who recognizes this geological signature today may be standing exactly where thousands of others walked past yesterday. Not because the gold was visible, but because the evidence was. And once you learn to read that evidence, you stop seeing rocks the way everyone else does. You start seeing probability. Now step back. The staining isn't isolated anymore. An entire section of rock has changed color. This is hydrothermal alteration. And alteration tells a story of fluid movement, of chemical reactions, of energy moving through stone. The rock has been transformed, and transformation leaves evidence. When alteration appears, the next step is verification. Follow it. Map it. Compare multiple locations. Does it expand? Does it narrow? Does it connect to larger structures? Assumptions don't lead to discoveries. Verification does. Because one wrong conclusion doesn't just waste time. It can mean walking away from something extraordinary. Most failed prospecting stories don't begin with bad luck. They begin with incomplete understanding, with details that were seen but never fully interpreted. As the investigation continues, a larger trend begins to emerge. The altered zone follows a consistent direction across the landscape. It isn't random. It's controlled by something bigger, possibly a fault, possibly an ancient shear zone, possibly a deep-rooted geological framework. Then another detail appears. Easy to miss, easy to ignore. Small cavities inside the rock. Vugs. Some are lined with quartz crystals. Others are empty. Which raises a critical question. What used to be there? The textures suggest something more complex, something that didn't survive weathering. And complexity is exactly what draws attention. Because complex environments are where significant discoveries are made. But this changes everything. A dark coating appears inside select cavities, not everywhere, only in specific zones, and always aligned with the same structural pathway. That means it isn't random. It's part of a larger geological process. And if this mineral is what it appears to be, then this ridge may not just contain gold. It may explain why the gold concentrated here in the first place. And when that dark coating was finally analyzed, geologists discovered it wasn't just another mineral. It was the key that revealed how the entire gold system formed. What they found next changed everything. At first glance, the coating appears insignificant. A thin, dark film, easy to overlook, easy to dismiss. Yet experienced geologists know that small details sometimes reveal the biggest stories. Because minerals do not occur randomly, every mineral forms under specific physical and chemical conditions. And if this coating formed during the same event that created the surrounding alteration, then it may preserve evidence of the entire mineralizing system. The next step is analysis. Not speculation, not assumption. Evidence. A small sample is collected, prepared, examined under magnification, then tested. Because in geology, observations create questions. Data provides answers. Under magnification, the coating begins revealing its structure. Tiny crystals, interlocking textures, patterns invisible to the naked eye. The mineral itself is important, but the texture may be even more important. Textures reveal sequence, and sequence reveals history. Which mineral formed first? Which formed later? What fluids were present? What conditions changed? The answers are locked inside the rock. Millions of years ago, this landscape looked very different. Deep beneath the surface, fractures opened within the crust. Hot, mineral-rich fluids began rising upward. Those fluids carried dissolved silica, sulfur, iron, trace elements, and sometimes gold. As the fluids cooled, minerals began to precipitate, not all at once, in stages. Quartz formed, sulfides formed, alteration spread outward into the surrounding rock. Each stage left evidence behind. Each stage recorded another chapter of the system's history. This is where many people make a critical mistake. They focus only on gold. But gold is often the final result of a much larger geological process. The process matters more than the metal. Because if you understand the process, you can predict where gold is most likely to occur. That is exactly how major discoveries are made. Now return to the ridge. Notice how multiple clues are beginning to overlap. Quartz veins, sulfides, hydrothermal alteration, structural controls, dark mineral coatings. Individually, each clue may mean very little. Together, they form a geological signature, and geological signatures are what prospectors search for. Not certainty, probability. Every observation is added to the map, every sample is compared, every structure is traced. Because the objective is not simply to find mineralization. The objective is to understand the system. The better the understanding, the higher the probability of success. Then another possibility emerges. The ridge may not be important because of the veins themselves. It may be important because of where those veins intersect. Intersections matter. When multiple fracture systems meet, fluid flow often becomes concentrated. And where fluid flow becomes concentrated, mineral deposition can increase dramatically. Suddenly, the investigation becomes more focused. The target becomes smaller, but the potential becomes larger. New samples are collected. Some contain stronger alteration. Some contain more sulfides. Others contain almost none. That variation is valuable because geological systems are rarely uniform. The differences help reveal direction. They help identify where fluid activity was strongest. And where fluid activity was strongest, valuable mineralization is often most likely to occur. Then something remarkable appears. Not visible in the field, not visible on the outcrop, only visible under magnification. Tiny particles trapped within sulfide minerals, microscopic, barely detectable, yet incredibly important. Because gold does not always occur as visible flakes or nuggets. In many deposits, the gold is so fine that it remains hidden inside other minerals. Invisible to casual observation. Invisible even to experienced eyes without analysis. And that changes everything, because the discovery confirms something critical. The system was capable of transporting gold. The geological ingredients were present. The pathways existed. The fluids existed. The alteration exists. The evidence is no longer theoretical. It is measurable. But geology is rarely about a single sample. One sample proves possibility. A deposit requires continuity. Can the system be traced? Does the mineralization continue? Does the alteration expand beyond the ridge? Those questions remain unanswered. For now. Because every answer in geology creates another question, and every discovery opens another door. Most people see rocks. A geologist sees history. A prospector sees evidence. And sometimes, that evidence leads to something extraordinary. Not because gold is rare, but because the knowledge required to recognize it is. The clues were always there. The structures, the alteration, the sulfides, the hidden signatures recorded within the rock. The difference was never the landscape. The difference was understanding. And somewhere beyond this ridge, the system continues, waiting for the next clue.